Okay, in this video I'm going to look at an application of exponential functions in data modeling. So we're going to be looking at data that we know has got an exponential type of behavior, either because we know the process behind it is exponential in nature, or we take some data, we plot it, and the plot looks or takes the shape of an exponential function. So what we're going to be doing here is once we have that scenario, we're going to be looking at how we can find an equation that best describes or models that data. So we're going to be looking at cases where the data either grows or decays, okay? And then what's going to happen is we're going to fit an equation of the form a times b to the power mt. Now a is going to be the value of p when t is equal to 0. So this is the value of p of t when t equals to 0. B is called the growth factor, and the growth factor is found by working out the consecutive ratios of the ratios of data in consecutive positions. So if you take the value at any time, you divide it by the value before it. So this is the growth factor obtained by computing ratios. And then the last one is m. M is the number of times we compound in a given time period. So this is the number of times we compound in a given time period. So our time period could be years. So time period is going to be our t here. Could be years, could be months, could be weeks, could be days, could be hours, it could be minutes. So if it's years, for instance, we ask the question, how many times do we take our data in a year? Okay. Right, so let's look at some examples of how this works. In the first example here, we've got world population, which has been growing exponentially during the past century. We have got a table showing the world population in billions over a 40-year period. This is our table here between 1970 and 2010 inclusively. Okay, so the first question is, can we derive a regression formula of this nature where t is time in years? And then we're going to use the formula to predict the world population in 2020. So the first thing we're going to do is we are going to let 1970 be our reference year. So that means for 1970 t is going to be 0. So this is going to be t equals not 20 but 10, 20 here, 30 and 40. And then to compute b, we need to work out the ratios between consecutive values. So we're going to have 4.52 over 3.91 here, 5.22 over 4.52, etc. So if we find all of them, we've got 1, 2, 3, 4. Then we're going to do an arithmetic mean of them. So when we do that, we get 1.155. So that's going to be our value of B. So B is sorted out. A is the value of the population when t equals to 0. So in our case, it's simply going to be 3.91. Then M is the number of times we compound, in this case per year. So here the population is taken once every 10 years. So that means in a year we compound 1 over 10 times. Because if we take the population 10 times in a year, then M is 10. But in this case, we take it once in 10 years. So M is going to be 1 over 10, or 0.1. So we now have our equation. So our equation going to be 3.91 times 1.155. Then M is 0.1 times t. So that is going to be our model or formula. Then can we use this to estimate the population in 2020? Well, in 2020, t is going to be 50. So we're going to plug in 50 here. So it's going to be P of 50, 3.91 times 1.155 to the power 0.1 times 50. And then we simply punch this in the calculator. Okay, so we're just going to punch this in the calculator. So we have got 3.91 times 1.155 raised to the power 0.1 times 50 is just 5. So it's going to be 8.04 billion. So I've got 8.04 billion. So it would be interesting for you to check what the world population was in 2020 and see how well it compares with this one. Okay, let's look at one more example. All right, in this example, we have got the revenue in millions of dollars obtained after the release of a movie. So this is shown in 2-week intervals. So on week number 1, this was the revenue. Week number 3, week number 5, that's revenue, etc., up to week number 11. So again, want to derive an exponential formula and then use the formula to predict the revenue in week number 12. Right, the first thing I want to do here is we are going to use week number 1 as our reference. So it's going to be 0. That is going to be 2, 4, and that's going to be 6, 8, and that is going to be 10. Then we're going to divide these. So 11.35 divided by 47.7. Here 4.68 divided by 11.35. 1.34 divided by 4.68. 0.49 divided by 1.34, and lastly 0.2 divided by 0.49. Then it's going to be like 1, 2, 3, 4, 5 of these, and we're going to take a mean, or the simple mean of all of them. So that's going to give us B. So we've got 11.35 35 over 47.7, 4.68 over 11.35, 1.34 over 4.68, 0.49 over 1.34, and lastly 0.2 over 0.49. So this is going to be divided by 1, 2, 3, 4. It's going to be divided by 5. So let's see what this works out to. So we have got 11.35 divided by 47.7. We've got 4.68 divided by 11.35, 1.34 divided by 4.68, and then we've got 0.49 divided by 1.35. Sorry, this is 1.35 here. 0.49 divided by 1.35, and then lastly 0.2 divided by 0.49. Okay, and this gives us 1.7, and then we're going to divide that by 5. So we have got 0.34197. I'll just keep it exactly as it is in the calculator, but for the sake of our 34197 write up 0.34197. So that's going to be our B, and 47.7 is going to be our A. So that means our revenue going to be 47.7 times 0.34197. M, we have got figures every 2 weeks, so that means weekly we're taking half, we're compounding this every half. It's going to be half because we are taking a value every 2 weeks, so M is going to be 0.5. so that's going to be our formula. Then for week number 12, using this time that we have adopted here, so week number 11 is 10, so week number 12 is going to be 11, so this is going to be R of 11, 47.7, 0.34197. If we can use the exact value here from the calculator, then our answer is going to be even more accurate, and that's exactly what we are going to do. Since we still have it on screen, we're simply going to say answer raised to the power 0.5 times 11, and then you're going to multiply that by 47.7. okay, so that's going to be 0.13 billion in week number 12. Okay, it's going to be $0.13 billion. Okay, at this point we're going to give you just one to try out, so that you can see whether you understand this. You can pause the video. Just let's find it for you first. Okay, in this example we have got the concentration of a drug after administering an injection in milligrams. So the concentration is taken every 5 hours. And here are the values. So you are to derive a regression formula of this form, where t is time in hours, and then use your formula to predict the concentration after 30 hours. Alright, so if you just want to pause the video, have a go at this, then afterwards when you press play, then you can compare with our solution. Alright, so in this case the ratios are going to look a bit like what we have here. We've got 1, 2, 3, 4, 5 of them. So we add and divide by 5. And that gives 0.565 as our growth factor. Since time t equals to 0 corresponds to 1000, our A is 1000, so that's going to be our formula. We are taking the concentration every 5 hours, so that means compounding 1/5 times per year, so it's going to be 1/5 there, or 0.2. So then after 30 hours we simply plug in 30 there, because our model is starting from 0 anyway, and we find that after 30 hours the concentration is going to be 32.5 milligrams. Alright, thanks for watching. Hopefully this is useful. Please do not forget to subscribe so that you can get notified whenever I post new material. Thank you.